Now today we will see the nature of the object and we will understand that what is the stress and the strain terms are. So here it is very interesting to know that what is the stress and strain term. To understand this phenomena, what we need over here, that we can say that when force are applied on a body in such a manner that the body is still in a static equilibrium, it is deformed to a small or a large extent depending upon the nature of the material of the body and the magnitude of the deforming force. The deformation may not be noticeable, but it is always there. So sometimes it is happens. Here we can see that in figure 1 above, if we consider that some object is given, say the length of the object is suppose L. Now we apply some external force over it. Suppose this is one metallic object, a strong metallic object. Now when it is strong metallic object, we found that when we apply some external force, whatever deformation will occur, it is not easily visible, but it is always there. So we have shown the deformation took place, that is very small, but still it is not easily visible. While in the same case, if we apply external force over a body like a rubber or some elastic material, then we find that the deformation is very easily visible and on a large extent, but at the same time also the body produces restoring force against this external force. So the deformation may not be noticeable sometimes visually, but it is always there. Now when body is subject to a deforming force, a restoring force is developed in the body itself at the same time simultaneously. This restoring force is equal in magnitude but opposite in direction to the applied force. So this restoring force FRE is equal in magnitude but opposite in direction to this external force. The restoring force per unit area is defined as stress. So here we can define the term stress as it is. So now first we define the stress, that is restoring force per unit area. So here the term, that is restoring force per unit area, it is called as stress. Now obviously here we can again see that if F is external force on any body and capital A is area of cross section of the given substance, then the magnitude of stress is given by the ratio of force and area. So this magnitude or the ratio force upon area is termed as stress. Now obviously from the equation given, the unit of force is Newton and unit of area is meter square. So the unit of stress is given by, that is Newton meter square, Newton per meter square, or Newton meter raised to minus 2. But this is the same unit for pressure also, and so it is also given as a Pascal unit, and they are having the same dimension on the basis of that. Now suppose we want to find out the dimensional formula of stress. So obviously the dimensional formula of force is given by, that is, m1 l1 t minus 2, and dimensional formula of area is given as L2. Then we can have the dimensional formula of stress. Here we can say that the dimensional formula of stress is m1 l minus 1 t minus 2, and it is defined here. So this is the dimensional formula of stress. So this is the information about how the stress is defined. Now, now we understand that how many stress and what are the types of stress are there. At the same time, we want to understand the strain. So first we say that what is the stress. So here we have shown that stress is actually the restoring force per unit area. At the same time, we also define one new term, that is a strain, that we will define later on, but we understand it that the strain is the change in the dimension of the object to its original dimension. So the ratio of change of the dimension to its original dimension, that is considered as a strain. So first we define something regarding stress, and afterward we define the term strain in detail. So here first we define the types of stress. To understand it, we go with a simple example, that stress is symbolically written as a sigma. Now, what is the case that we want to define? Here we say that suppose we are given a cylindrical object of length L as shown in the figure above 1. Now, suppose we apply external force on it such that it will extend its length both the side, and we again say that we applied equal force on both the side. So if equal force applied on both the side, under the influence of this external force, object has increased its length. Now the increase in its length is supposed delta L as a whole. So the new length will be L plus delta L. Now the delta L is change in its dimension, but here it is the new length. So that force which increase the length of the body, it is considered as a tensile force, and therefore the stress that termed over here is called as a tensile stress. So here in first case, the first type of stress that we have defined as tensile stress, that is under the tensile force. Tensile force means which is generally termed that is responsible to increase the length of the substance or body. Now another type of stress that we can define as compressive stress. So obviously here from the figure we can say that the external force is applied on the body in such a manner that its original length decreases from both the sides. Suppose the total decrement in the length is suppose delta L, then new length of the substance will be L minus delta L. Again as in the above case. The force which was used to increase the length was considered as a tensile force. Here, the force which is used or which is responsible to decrease its length or to compress its length, the force is called compressive force. Now, the stress under this compressive force is considered as compressive stress. Now, it is very clear that under the tensile stress, the length of the substance increases and it becomes L plus delta L. But at the same time, the restoring force is exerting on the body in opposite direction to the external force. So here, in each of the case, we can define and we can say that suppose here this is F external, then F restoring is acting inside of the object, that is in opposite direction. Here also, if this F external is a compressive, then restoring force is again in opposite direction to the substance, that is I have shown with the red arrow. Here also that we have to remember that F and F restoring are equal in magnitude. So F external and F restoring are equal in magnitude but opposite in direction. So if we want to write in a vector form, we can say that F is equals to minus F restoring, because they are equal in magnitude but opposite in direction. Now, from all about this information, we can also term these tensile and compressive stress in a single common name. This single common name is given as a longitudinal stress. That is, tensile and compressive stress are also given a common name, and that is called as longitudinal stress. Here, the longitudinal stress in general defined as a sigma L, that is F upon A, and now this is the common understanding of the stress. Now we want to understand the term strain. Now to define it, we can say that the change in the dimension, here the case we have length, that is delta L, to its original dimension, that is that original length L, is called strain. Here in our case the changes are there in a length, and therefore that is called longitudinal strain. So again, the change in the dimension to its original dimension is called strain. Here we all have taken in above case, that is a changes in a length, and original length was considered as L. So the ratio of delta L and L is called as strain. So here longitudinal strain is termed as epsilon L is equals to delta L upon L. Here it is very clear that delta L and L both are the same dimension, that is length to length, or the ratio of length to length, and therefore we can say here that this is dimensionless. So longitudinal strain or a strain is dimensionless and unitless. Now we move further. Again we define that the types of stress and strain. Here we have defined that first type, that is longitudinal type of stress, that is defined by sigma L, that is equals to F upon A. At the same time, we have defined the second type of strain, that is epsilon L, that is delta L upon L, that is the change in length upon its original length. Now we will move to the next type of stress and strain, that is tangential or shearing stress and strain. So what is different in this case from the previous case? Let's see that generally what is the term tangential means. So if two equal and opposite deforming forces are applied parallel to the cross sectional area of the cylinder, as here I have shown in this figure above. So when two equal and opposite deformation forces or deforming force, so here from figure we can see that here from the center part we can define that we have applied some deforming force. So when two equal and opposite deforming forces are applied parallel to the cross sectional area of the cylinder, as shown in figure above, there is a relative displacement between opposite faces of the cylinder. So here we consider this is one face of the cylinder, and at the same time this is second face of the cylinder. So when this external force applied on the body on the surface or parallel to the surface, it will experience a relative displacement, and that is defined as that tangential stress. Now we see how it is there. Now the restoring force per unit area developed due to applied tangential force. So this force is nothing but this tangential force is known as tangential or shearing stress. Now we can say due to this F external, see it is very important to understand, due to this F external, the displacement of the substance is about delta x as shown in the figure. Here it is shown in the figure that it experiences some delta x displacement, and due to that we define that the stress developed over here due to the tangential force, it is considered as tangential or shearing stress. Again it is defined in the same manner that it is tangential force, that is tangential restoring force upon unit cross section area. But for strain, here it is interesting thing, how to define strain over here. So to define strain, we can say that as a result of this applied external tangential force, there is a relative displacement, that is delta x, between two opposite faces of the cylinder as shown in the figure above is observed. The strain so produced is called as a shearing strain, or it is defined as the ratio of relative displacement of the faces delta x to the length of the cylinder L. So the shearing strain as defined in this case is given as delta x over L, and it is also a very small angle that is defined by tan theta. We know that from the figure, tan theta is nothing but opposite upon adjacent side. Here the adjacent side is already having length L, and the deformation is produced on opposite side, that is delta x. So we can define here tan theta is equals to delta x upon L. Now, where theta is angular displacement of the cylinder from the vertical original position of the cylinder, and usually theta is very small, and therefore tan theta is nearly equal to the angle theta. We can understand that if theta is even 10 degree, for example, there is only 1% difference between theta and tan theta is observed. So this is called the stress and strain in the form of tangential or a shearing form. So the tangential shearing stress is given by F over A, while tangential or shearing strain is defined as delta x upon L. It is also termed as a theta delta x upon L, or it is only written as a theta, that is delta x upon L. Now, the third type of the case. Here again we have to note that the same type of example is observed. It can be visualized when a book is pressed with hand and pushed horizontally as shown in figure, as we can understand that suppose I have given any book like material, say some book like material is there, we are given, and suppose it is put under the some external force in such a manner that it experiences the force in the direction. Here we can say that this is the direction of the force, or it will also experience the force from the bottom part. So we found the tangential stress and strain observed and developed in the book as well. So these are the examples of shearing stress and shearing strain. Now the new term, that is part 3 or type 3 of stress and strain, that is volume or hydraulic stress or strain. Now we see that how it is defined. So to understand it, we say that suppose a solid sphere placed in a fluid under high pressure is compressed uniformly on all sides. The force applied by fluid acts in a perpendicular direction at each point of the surface, and the body is said to be under hydraulic compression. So that is explained here with the figure. We can say that when the object is kept in a fluid, it experiences the hydraulic pressure, and the volume of the substance decreases uniformly from all the direction. We can see here this is the case. It has decrement in its volume from all the direction, and that is considered as a new example, that is hydraulic stress. So when a solid sphere placed in a fluid under high pressure is compressed uniformly from all sides, the force applied by fluid acts in perpendicular direction at each point of the surface, and the body is said to be under hydraulic compression. This leads to the decrease in its volume without any change of the geometrical shape. So here the shape will not going to be changed, but its volume automatically decrease. So suppose the sphere remains as it is as a sphere. Suppose a triangle remains as it is as a triangle, but its volume is found to be decreased uniformly from all the sides. The body develops internal restoring force that are equal and opposite to the forces applied by the fluid. So here, in each case, in each above case, the body itself try to apply some external force on each point where the external force is applied. It tries to apply some internal force opposite to this, exactly in opposite direction to the external force. Now this term, that is, a body develops internal restoring forces that are equal and opposite to the forces applied by the fluid. The body restores its original shape and size when taken out from the fluid, and therefore the internal restoring force per unit area in this case, here internal restoring force is indicated by blue lines. So the internal restoring force per unit area in above case is considered or known as hydraulic stress, and in magnitude it is again equal to the hydraulic pressure because it is equal from all the direction and it is perpendicular on each part. So pressure is defined as perpendicular force per unit area, and the definition of pressure is fulfilled here. So we can say that this hydraulic stress is also considered as hydraulic pressure. Now about the strain, here we can say that the volume decreases uniformly. So the strain produced by the hydraulic pressure is called volume strain, and it is defined as the ratio of change in volume, that is delta V, and to its original volume, that is V. So the ratio of delta V upon V is considered as a volume strain also, and it is here the third type of the stress and strain. So ultimately we have total three type of stress and strain. So in general, when we want to define, we have three types of stress and strain. Simply three types of strain and stress, that is